start with or to introduce, how can you define the gyroscope? A gyroscope is a device which is used to maintain stability. Listen carefully. Gyroscope is a device which is used to maintain stability or to maintain a reference direction. To maintain a reference direction, specifically in navigation systems or airplanes, that is aeroplanes or aircrafts and all. Okay. So gyroscope is a device which is used to maintain stability or to maintain reference device or reference direction in navigation systems. Okay. So you can say this is a short introduction of the gyroscope. But to understand the concept of gyroscope, let us move forward. Okay. So first of all, let us understand what is angular velocity. Now I think you already have studied this angular velocity from I think 11th standard, right? In physics or in maybe in a 12th standard also. Okay. So basically, what is angular velocity? Now, why I am starting with angular velocity? Because you have to understand some rules. Because finally, this gyroscopic concept is related to the angular velocity, angular acceleration, or you can say the torque or a couple. Okay. So first of all, you can see a small disk which is spinning around the shaft AB at an angular velocity omega. Okay. Can you see? Can you see a small disk at small disk on your screen? Okay, so you can see a small disk which is, you can say, rotating at an angular velocity omega radian per seconds, right? Okay, so about this point AB or about this shaft. Okay, then the rate of change of angular displacement. The rate of change of angular displacement is nothing but the angular velocity. So basically, we know that it is a vector quantity, right? It is now. This is the definition, the rate of change of angular displacement. Okay, that is dx upon dt. You can call it dx upon dt or ds upon dt, right? So that is equal to velocity. Okay, so this is what we know, this dx upon dt or ds upon dt, rate of change of displacement. Okay, so you consider s or x as a displacement, you will get this ratio. Again, it is a vector quantity. Okay. It is a vector quantity means what? It is represented by drawing a vector. Now, in the gyroscopic concept, this is very, very important. Today, in this first 1 or 2 slides, we will understand how to draw a vector diagram. Okay, because to solve the problems, to understand the concept of gyroscopic couple, it is very, very important that you should be able to draw a vector diagram. You should be able to draw a vector diagram. Okay. And why you are able to draw a vector, how can you draw a vector diagram? We'll understand. Okay. So first thing is that it should be a vector quantity and angular velocity is a vector quantity. So that is why you can represent by drawing a vector. Okay. So now I think you know this already, but once again I will explain what are the considerations while drawing a vector? How do you draw? Okay. So it is specified by first a magnitude. It is what is a magnitude? Okay, so what is the magnitude? That is magnitude in terms of radian per second. Maybe 20, 30, 40, 50, 100. What is the magnitude? Okay, this is one thing. Next, the direction of the axis of rotor. Second thing, what you have to consider, the direction of axis of rotor. And third thing is the sense of rotation of the rotor. Means what? Whether that particular disc, let us say this is a disc now. So you have to understand what is the magnitude at which disc is rotating. What is the direction of axis of rotor? What is the sense of rotation of rotor? That is, disc is rotating clockwise or counterclockwise. Is it clear? These are the 3 things. Is it clear or not? Okay. So first, magnitude. How do you represent the magnitude? You represent the magnitude by considering it equal to the length of the vector. So length of the vector will be equal to magnitude. Then direction of axis of rotor by drawing the vector parallel to the axis of rotor or normal to the plane. By drawing a vector parallel to the axis of rotor or normal to the plane. Okay, and then third one is sense of rotation. Now, for example, in this case, okay, now let us say AB by drawing a vector parallel to the axis of rotor. Now, what is the axis of rotor? Let us say this is the axis of rotor. Okay, I am drawing this parallel. Let us say the length I am representing is A into B. Okay, now this AB, the length AB represents the magnitude. Okay, and this AB is nothing but I have drawn it parallel to this axis, that is AB. Okay, so parallel to this I have drawn this AB, right? Now these 2 things I have already done. Now third is what? A sense of rotation of the rotor, that is a clockwise or counterclockwise, is denoted by using a right hand screw rule. Now everybody know what is right hand screw rule. Okay. Now two things I have already mentioned. The magnitude I have represented by the length AB. So let us say length AB is something, some centimeters. Length AB is some centimeter, and I have drawn again. I have drawn parallel to the axis of rotor. I have drawn parallel, which represents the direction of the axis of rotor. Now I have to represent the sense of rotation, whether it is clockwise or counterclockwise. Okay. So first of all, you have to identify some observer. So let us say this is the position of the observer. Okay. Now this is the position of the observer. Clear? Now it is very important to understand the position of observer from which side you are looking. So can you see where I have shown a position of the position of this? Okay. Now first of all, tell me what is the right hand screw rule? What is the right hand screw rule? Can anybody tell me what is right hand screw rule? Maybe in your home, you might have tightened the screw with the help of a screwdriver. Have you done this process? Have you by any chance tightened or loosened the screw by using a screwdriver? So tell me what happens exactly in this. Let us say that if the screw with the help of a screwdriver is rotated in a clockwise direction. If you rotate the screwdriver or a screw in a clockwise direction, what happens? That screw moves away from you or that moves towards you. Can anybody tell me? Yes? Yes, my question is very simple. That is, this is a small activity which you have already done. If not done, by today itself you can do it. Yes, anybody? What happens when
Moves
you
away from us.
yes, move away from the observer? Similarly, and vice versa, if you rotate the screwdriver or maybe a screw in a counterclockwise, that is anti-clockwise direction, what will happen? It will move towards the observer. So this is what you have to remember while drawing a vector diagram, because see, complete model or complete analysis depends upon the drawing a vector diagram. Unless and until you are able to draw a vector diagram, you cannot solve the problem. You have to forget about this model. So maybe you understand the concept, no issues. But this vector drawing a vector diagram is very important. So first thing is that you have to understand here. In this case, if looking from the observer end, looking now you can see this is the observer. Now looking from the observer end, now you can see that this omega is, let us say, counterclockwise. This omega is counterclockwise or clockwise. Now what will happen if the omega is clockwise? Okay, let us say omega is moving clockwise. Means what? This disk is rotating clockwise. What will happen? You can see that this is the observer. Okay, so you can see that the arrow will be towards the point B. Arrow will be towards the point B, right? Why? Because the movement, the rotation is clockwise. So as per the screw rule, you can show the arrow towards the B point. Okay, and if the disk is rotating anti-clockwise, what will happen? You have to show. Let us say this is the observer. Okay, so you have to show this arrow towards the observer. Okay, so this is called the screw rule. Okay, so I am writing here. This is the observer. This is the observer. Okay, so this first case is what? This first case is clockwise. Okay, this case is anti-clockwise. Okay, so I have drawn this vector diagram and I have assumed that observer at this descent. Okay, so looking from the observer end, if the disk is rotating clockwise, okay, you can represent the arrow away from the observer. If the disk is rotating anti-clockwise, you can represent the arrow towards the observer. This is how. So this is the third case. So first case is what? Represent magnitude by showing the length of the vector. Draw the length of the vector. Second case is direction of the axis rotate. So I have shown this direction A and B. Okay. Now sense of rotation. Either it may be away or either it will be towards the observer. Now message me. Have you understand this? Anybody? The first thing. Have you understand? Message me yes or no. The first concept you have understand or not? Okay. Okay. So basically the first thing you have to look, where is the observer? Whether the body means what? Maybe a disc or maybe any shaft. Whatever will be the body is rotating clockwise or counterclockwise. So accordingly represent the sense of rotation of the rotor, okay, by using the light and screw. Okay, next is what gyroscopic acceleration. Okay, now gyroscopic acceleration is denoted by, let us say, alpha. Now, first of all, you know what is angular velocity. The first point I have explained you, because unless and until you understand the angular velocity, you will not understand the angle. So gyroscopic acceleration means what? Angular acceleration only. Okay, you know what is angular acceleration? Rate of change of velocity with respect to time. Okay, but here we are specifying it as a gyroscopic acceleration because we are understanding the concept of gyroscope. So in a gyroscope, what is gyroscopic acceleration, or how do you calculate? Okay, so angular velocity was denoted by omega. Okay, we have understand about it. Now let us say that gyroscopic acceleration is denoted by alpha. So let us understand or derive a formula for this alpha. We have to derive a formula for this alpha. Okay, so basically, first of all, what is angular acceleration alpha? Angular acceleration alpha is equal to rate of change of velocity dv with respect to time, dv by dt. Rate of change of velocity with respect to time. Okay. Again, it is a vector quantity. Okay. So you can represent. Since it is a vector quantity, you can represent by drawing a vector diagram. You can represent by drawing a vector diagram. So 1, 2, and 3. It's a rate of change of velocity with respect to time, rate of change of angular velocity. So I will write it as d omega, rate of change of angular velocity, that is d omega by dt, basically, because I am talking about the angular acceleration. So rate of change of angular velocity with respect to time, vector quantity, and you can represent by drawing a vector diagram. Okay. So let's start. I will take one example of a small disk. Okay. So first of all, let us consider a disk which is spinning about the OX. What is this? This is disk. Okay. This disk is spinning. What is happening? This disk is spinning about OX axis. Okay. This disk is spinning about the OX axis. Okay. And let us take some observer. So let us say that the direction of weaving is this one. Means what? This is your observer. Okay. Is it clear? So I will mark the arrow maybe in this direction. Okay. Because my direction of weaving is this side. So what I mean to say is that OX is nothing but the axis about which disk is spinning. Okay. So this OX, this axis is called as the axis of spin. What it is called as the axis of spin. So today in this particular model, we will understand the three axes. We are going to understand the three axes. If I draw a diagram like this, okay. So let us say this is OX, this is OY. So today we will define what is OX, what is OY, and what is OZ. Because unless and until you understand the three axes, you cannot understand the gyroscopic concept. Okay. So is it clear from your side? Okay. So let us say that if the observer is looking from this, if this is the observed position, this disk is rotating in anti-clockwise direction. Now this is very, very important. Now if I say that you draw a vector diagram. Okay. Later on we will be drawing a vector diagram. But if I say draw a vector diagram, how will you draw this OX parallel to this OX? Okay. Here is your observer. The disk is rotating at a counterclockwise direction, so it will be towards the observer. Okay. So this is nothing but a vector diagram for this particular OX, and you can represent this with the omega. Okay. So what is this OX? This OX represents a vector diagram for a angular velocity omega for this axis OX. Is it okay? But that is another part. First of all, we'll understand this one. Now till now we have understand that I have taken an axis OX. The axis, so what is axis of spin? The axis about which this disk is spinning, this disk or body is spinning, is called as the axis of spin. So tell me, have you understand this much? I hope you have understand this much. Okay. Next. Now let us assume something. Now let us assume that after some short time, means after some time, let us say the time is dt. Now what is dt? First of all, what is this? First of all, you understand that del is nothing but the infinite infinite simul infinite simul time. Okay, means what? It is a very small. Okay, small time. So del represents infinite simul time or a very small time. Okay, so that is very important you have to understand. So that is why I am considering. See, my statement बघा माझं काय. After some short interval of time, let us say that this disk is spinning about a new axis. Okay, so what is this new axis? What is this new axis? OX dash. So what I meant to say is that initially disk was spinning about the OX. Disk was spinning about the OX, looking from this direction, observer, and rotating in an anti-clockwise direction. Now, after some time, let us say that time is delta t. Now, your disk is spinning about the new axis of rotation. And what is that new axis of rotation? OX dash. Now you will ask her how this happened. Okay, let us understand that afterwards. That how this axis OX turn into the new axis OX dash. Okay, basically how it happened. Obviously, you might logically understand that you have to apply some torque. Okay, means what? Let us say if I am applying some torque, if I'm applying some torque or if I'm applying some couple, right? This torque or couple, if you apply or this at this OX, now this torque or couple which you are applying is called as a applied torque, is called as a applied torque or couple. So whenever you are applying a torque or a couple to this OX axis, this OX axis will turn to its new position, that is OX. Okay, that we'll understand later on because we have to understand the next concept which is called the gyroscopic couple or gyroscopic torque. So this torque or couple which is called as the applied torque or couple, we have to calculate a formula for that. Okay, but that is a next part. So here we have to just understand that initially the disk was spinning about the axis of pin OX and now it is spinning about this axis OX which is a new axis. Okay, is it clear? And this new axis is turned at an angle del theta. This new axis is turned at an angle del theta. So del theta is the new angle and del t is nothing but a short span of time after which this disk is spinning about a new axis. Okay, is it clear? Now let us say that initially your disk was spinning at an angular velocity omega radian per second, but after some time del t at an angle del theta, this new axis is now OX dash, and now again at a similar direction, that is anti-clockwise. Now we can understand that, or we can consider that the disk is rotating at new angular velocity, which is nothing but omega plus del omega. Now message me, have you understand this? इथपर्यंत तुम्हाला समजलं का बघा. This is a starting phase which you have to understand. Have you understand this or not? Have you understand what I am trying to do? I am trying to calculate a angular acceleration alpha. For that, I have considered a small disk which was spinning about the axis of spin OX. OX is equal to axis of spin. Okay, my direction of moving is this. Initially, omega was the angular velocity of the disk. Now, after some short span of time, I am saying that now disk is rotating about the new axis OX dash. So OX dash is nothing but the new axis of spin. Okay, so it happened at small time del t at an angle del theta. So the corresponding angular velocity is nothing but the omega plus del omega. Okay, now tell me, have you understand this or not? Have you understand? Now we will draw a vector diagram. Now this is, you can say the original diagram. Now we will draw a vector diagram. Okay, vector diagram from this actual diagram. Have you understand this actual diagram which I have considered for analysis? See, I am keeping it simple. I am trying to calculate the angular acceleration. So I consider a small disk, and now I am drawing a vector diagram, and then I will calculate the formula. Because from vector diagram, you will get a derivation of the formula. Chalo, have you understand this? Be fast. Please message me fast if you understand this. Guys, I have a very short span of time, so please message me. Okay, everyone. Okay. Chalo. Now let us draw a vector diagram. Can anybody explain me how to draw a vector diagram? Can anybody tell me? Okay, chalo. I will start. So first of all, OX represents. What does this OX represent? Okay, this OX is nothing but a vector OX. Okay, So this vector OX represents the angular velocity omega of this disk. Have you understood or not? This vector OX, which I have drawn here, represents the angular velocity omega of the disk. हे सगळ्यात पहिलं समजून घ्या. जेव्हा तुम्ही वेक्टर ड्रॉ करता, ओके, इथे तुमचा ऑब्झर्वर आहे, लेट अस से देयर इज ऑब्झर्वर, द दिस वेक्टर हा काय रिप्रेझेंट करतो ते महत्वाचं आहे. द वेक्टर OX represents the angular velocity omega of this disk. Okay, I hope. Means what? How you draw the vector? You are drawing a vector. Well, let us say the omega is equal to 20 radian per second. So this OX represents omega is equal to 20 radian per second by drawing OX vector OX is equal to some 20 centimeter maybe. Okay, so this 20 centimeter vector OX is equal to 20 centimeter represents this omega is equal to 20 radian seconds of this disk. I hope you understand this. Okay, so magnitude and direction. And next, okay, now tell me where I will show the arrow. Let us say the observer is here. Observer is here. Now tell me the arrow will be towards the observer or away from the observer. The vector, where you have to show the vector arrow, towards the observer or away from the observer is here. Towards. Why towards? Why towards? My question. Let me understand. You have understand or not?
Direction is counterclockwise.
Yes, when you are looking from this direction, direction is counterclockwise. I am very happy you are getting it. Okay, chalo. So I have shown this arrow. Okay. Now let us say that this new axis of spin OX dash. Now this new axis of spin OX dash, it has angular velocity omega plus del omega. Okay. So this vector OX dash, what it represents? It represents the angular velocity omega plus d omega of this disk when it is rotating at about the new axis of spin. म्हणजे जेव्हा तो इथे होता, जेव्हा ह्या ऍक्सिसला होता, तेव्हा it represents OX. When it came to this axis, it represents OX dash. So I have shown the two vectors. Okay, I hope you understand how I am going. Okay, please try to remember. This is the observed position. Okay, next. So let us say that again arrow will be towards the OX dash. Okay, arrow will be towards the X dash because arrow will not change again because the direction is obviously means what? Observer position will change. Na? For example, if this was the observer position, let us say now the observer is here. Okay, so from this position also it is counterclockwise. So it is the arrow will be towards the X dash, that is towards the observer. Okay, so see, even if the position is changing, guys, what important you have to understand, मी पुढे तुम्हाला सांगणार आहे, even if the position is changing, this plane is same. This plane is same. OX, you know, this plane is same, na? This plane is same. I hope you understand this. Okay. I will talk more about the planes in the later slides. Okay. So you got now this x dash. This x dash. Let us say, see how you are moving. You are moving from x towards x dash. You are moving from x towards x dash. So my arrow will be like this. So you will get a new, you can say a vector that is a x dash. Now can anybody tell me what does this vector x dash represent? Yes. Can anybody tell me what does this vector x dash represent? See, vector OX represents angular velocity omega of a disk. Vector OX represents the angular velocity, new angular velocity omega plus del omega. Then after drawing a vector diagram, I am getting a vector x dash. Can anybody tell me what does this vector x dash represent?
Change in angular velocity.
Yes, very nice, very nice. It represents the change in, and it is very, very important to understand, it represents the change in angular velocity. Change in angular velocity of what? Of rotor. Of rotor means what? This disk. Okay, and it is very, very important to understand that after a time del t. So after time del t, x dash represents the change in angular velocity. Okay. Now guys, anybody tell me this vector x dash will have its two components. Can anybody tell me? Now I have to resolve this. This vector x dash will have a two components. Can anybody tell me what are the two components? One will be
radial tangential.
Yeah, one will be tangential component and another will be a centripetal. Centripetal means what? It is a radial component. Okay. So first of all, tangential component. Now tangential component, let us say represented by XR. Okay. Tangential component. So XR is nothing but a tangential component. Okay. I think you have done this in the kinetics of machinery. Same we are applying here. And then this XR, this XR is parallel to OX. This XR is parallel to OX, and this OX perpendicular to X dash R, perpendicular to X dash R, and this X dash R, which is perpendicular to OX, is nothing but a radial component. Radial component is also called as a centripetal component. Centripetal component. Okay. I hope it is clear to you now. Okay. So let's do the analysis fast. Now tell me, before I move to the analysis, now analysis करायचं म्हणजे काय करायचं आहे? I have to do analysis of XR and I have to do the analysis of X dash R. That is a centripetal component and a tangential component. But to get these two components, I have to first of all draw this vector diagram. Now tell me, have you understand how to draw this vector diagram or not? Be fast. Have you understand how to draw the vector diagram or not? I think you have understand this. How I have drawn this vector diagram. Yes. Okay. So don't remember any thumb rule and all. You can also remember the thumb rule, but it is complicated. Remember the right hand screw rule. It is very easy to remember. Okay. Chalo, next. Okay. So first of all, we'll start with the analysis. First of all, we'll talk about the component of angular acceleration in the direction of OX. Component of the angular acceleration in the direction of OX means what? It is nothing but a tangential component. It is nothing but a tangential component. Okay. So now you know that tangential component is denoted by what? Tangential component is denoted by alpha t. So what is alpha t? Alpha t is nothing but a xr upon del t. What is xr? See, it is acceleration. Na? xr is nothing but a change in angular velocity upon change in time. Okay. What xr is nothing but the change in angular velocity upon change in time. So alpha t is nothing but a tangential component which represents the component of angular acceleration. What is angular acceleration? Alpha. See, alpha has two components, alpha t plus alpha c. And alpha c is the radial component, alpha t is the tangential component. And I want to calculate alpha, total angular acceleration, which is, and this total angular acceleration, if you want to calculate, I have to calculate alpha t and alpha c. Okay, so I am interested in alpha. So I have got alpha t. But now, what is xr? What is xr? Xr is nothing but OR. This total OR minus this OX will give you xr, right? So OR minus OX upon del t. Okay. So I am just doing a geometry. Now what is this OR? See, now if you look at this triangle, if I draw this triangle, this O, R, and X dash, and if this is a del theta, so tell me what is OR? This OR obviously will be equal to what? OX dash into cos del theta, or you can write like this: cos del theta is equal to OR upon OX dash. Okay, so just a simple trigonometry, right? So I am writing here OX dash cos del theta minus OX upon del theta. Okay, now what is OX dash? What is this OX dash? OX dash is nothing but the W omega upon del omega, which is nothing but the angular velocity when the disk is or rotor is rotating at a new axis of spin OX dash, cos del theta as it is. What is OX? OX is nothing but omega, and del theta as it is. Okay. So now multiply the bracket omega cos del theta plus del omega cos del theta minus omega. Okay. Now, see, now already I have told you that del is nothing but the infinitesimally small. What do you mean by the del? A very small. Del is nothing but the very small. So since del theta is very small, you can substitute cos del theta is equal to 1. Okay. So I am substituting cos del theta is equal to 1. So I am getting omega plus del omega minus omega upon del theta. So from this omega and omega will get cancelled, and you will get alpha t, that is a tangential acceleration or a tangential component of an angular acceleration in the direction of OX. Alpha t is equal to del omega upon del t. So this alpha t is nothing but del omega upon del t. Okay. Now what is the next procedure? Take a limit. See, the procedure is same what we have followed in the mathematics. So in the limit, if I take a limit when del t tends to 0, what I am getting? Alpha t is equal to d omega upon dt. So when I am taking limit del t is equal to 0, I am getting this final. Okay. So now from this analysis, I got first component, that is a tangential component of angular acceleration alpha. Okay, clear? What is that? D omega upon dt. Now tell me any doubt in this? Before I move to the next component, that is a radial component, just tell me, have you understand this or not? Have you understand this or not? Have you understand how I find alpha t? Please be fast.
Yes, sir.
Okay. Chalo, next. Component of a angular acceleration in a direction perpendicular to x means what? Which component? Centripetal component or radial component. Now what is radial component? Rx dash upon del t. Okay, Rx dash upon del t. Now what is Rx dash? Rx dash is nothing but Ox dash sine del theta. See, initially for Rx, for this XR, I got cos term, and now for Rx dash, I'll be getting, see, if you look into this, particular triangle XR, okay, Rx dash, okay, what you will get? You will get Ox dash sine del t, okay, del theta. So this is simple technology. Now what is Ox dash? Ox dash is nothing but the omega plus del omega sine del theta t, okay, cross multiply the bracket. Again same, since del theta is very small, therefore substituting sine delta del theta is equal to del theta. Okay, we'll substitute that. So I am getting omega del theta plus del omega into del theta. Okay, now neglecting del theta. Okay, why you have to neglect this? Because this is very small. Okay, so I am neglecting that small components. So finally I am getting alpha c is equal to omega d in del theta upon del in limit you get. Okay, so I have got this component omega del d theta upon dt. Okay, now I have got both the components. So now have you understand how I got this component? Same. First is tangential component, second is a radial component. Okay, now once I have got both the component, next is very easy. Next is very easy. Okay, now basically here I am writing omega p is equal to del theta upon d theta. Now this term I will explain you later on. What is omega p? But now तुम्ही फक्त एवढंच लक्षात ठेवा that this d theta upon dt is equal to omega p. What is omega p? This term is very important. This omega p म्हणजे काय हे मी तुम्हाला पुढे सांगणार आहे, कारण आता सांगून ते तुम्हाला समजणार नाहीये. I have to show you some figure. Okay, but now you consider that alpha c is equal to omega into omega p, where omega p is equal to d theta upon dt. Okay, this is clear. Now let's move forward. So total angular acceleration on the disk. So now I have considered a disk, a rotor rotating about the axis of spin OX. Okay, so now what is the total angular acceleration on the disk? It is nothing but the alpha is equal to alpha t plus alpha c, and now this I will get alpha d is equal to d omega upon omega into omega p. Okay, so this omega is called as the angular velocity of spinning. Angular velocity of spinning means what? The angular velocity of a disk. Now see, this disk is spinning about the axis OX. This disk is, or a rotor is spinning. The disk is spinning, and at what velocity it is spinning? It is spinning at velocity omega, and that is why this omega is called as the angular velocity of spinning. Okay, and this omega p, now comes the term, this omega p is called as the angular velocity of the precision. This term you might haven't heard. Okay, now this term I will be defining you. Now I got a formula. Omega p is equal to d theta upon dt. But what is this omega p? This omega p is called as the angular velocity of the precision. Omega p is called as the angular velocity of a precision. Okay, now this angular velocity of a precision means what? Okay, now this we have to understand. Now tell me, have you understand till now what is omega and what is omega p? Now let us understand this concept. What is exactly a omega p and what is angular velocity? Now you have to remember that omega is the angular velocity of the spinning disk. The disk is spinning originally at velocity omega radian per second. This omega and omega p are not equal. First of all, you have to remember that. This omega p is angular velocity of precision, and omega is angular velocity of spinning. Now you will ask me, sir, what is this omega p then? Can anybody tell me what is this angular velocity of precision? Anybody knows this? Anybody knows this? First of all, I will explain you what is angular velocity of precision. Okay. Now let us understand first of all what is omega p, and then I will move on to the next part. Okay. Now to understand the omega p, again I will consider same diagram. Okay. Axis of spin. Okay. So this is now. Let us consider the new axis. and this new axis is called as a y omega. Okay, new axis OY. Okay, now this new axis, can you see the new axis? This new axis OY. Okay, this OY is called as the axis of precision. This new axis OY is called as the axis of precision. Okay, now what is omega p? Now let us say this is omega p. Let us say this is omega p, and this is what? This is omega. Okay, and what is this? This is omega plus del omega p. Okay, now what is first of all axis of precision? OY is equal to axis of precision. OY is equal to axis of precision. First of all, let us understand what is axis of precision. First of all, tell me, have you understand this axis of spin? Axis of spin is nothing but the axis OX about which this disc is spinning. Okay. Now I want to understand what is OY. Now this OY is nothing but the axis of precision. The axis about it. The axis I will write here. OX is equal to axis of precision. First of all, let us understand this, and then you will be able to understand this. What is omega p? That is the angular velocity of precision. So the axis I will write here. Axis about which? Axis about which? Can anybody tell me what will be the axis of precision? The axis about which? About which? Axis of spin. Very, very important. Axis of spin OX will turn. Right? It is okay? Have you understand? See, for example, you consider that OX was the original position. OX ही तुमची original position होती आणि ह्या OX ला मी काय केलं? एक torque apply केलं. I applied a torque. Or let us say I applied a couple. And because of this torque or because of this couple, see, it is a applied torque. तुम्ही apply करताय. तुम्ही apply केल्यानंतर त्याला नवीन पोझिशन काय मिळाली? OX डॅश मिळाली. म्हणजे जेव्हा तो इथून इथे जाणार आहे, when this x moves to x from x dash, it is moving to the new position. So when it is moving to the new position, ही तुमची जी ऍक्सिस आहे ना OX ऍक्सिस, it is turning, it will turn ना. मग हे जर तुम्हाला बघायचं असेल तर मला सांगा तुम्ही कुठून बघणार? You have to look from the top view. जर तुम्ही वरून बघितलात तर तुम्हाला असं दिसेल, व्हेरी व्हेरी इम्पॉर्टंट, इफ यू आर लुकिंग फ्रॉम द टॉप व्ह्यू, असं इमॅजिन करा की तुम्ही वरून बघताय तर तुम्हाला हे दिसेल, this axis OX is moving to its new position OX dash. While doing so, this axis is turning about some axis, and that axis is nothing but the OY, and that axis is called as the axis of precision. Means what? The axis about which the axis of spin will turn, or it is called as a precess. It will precess because it is not completely rotating. It is not completely spinning. It is just precessing. It is just turning. And the axis about which the axis of spin will turn or precess, that is called as the that is called as the OY, which is nothing but the axis of precision. And if you want to see this, तुम्हाला ते कुठल्या प्लेन मध्ये दिसेल? तुम्हाला ते फ्रंट व्ह्यू मधनं जर सॉरी टॉप व्ह्यू मधनं जर तुम्ही बघितलं वरून तर ते तुम्हाला दिसणार आहे. म्हणजे थोडक्यात तुम्हाला ते या प्लेन मध्ये दिसणार आहे. म्हणजे वरून बघताना तुम्हाला या प्लेन मध्ये काय दिसणार आहे? You will see that this axis of spin is precessing about this OY axis. Now guys, please tell me, have you understand this or not? Have you understand this? What is OY?
Yes, sir.
Okay. Can anybody tell me what is OY? Just I wanted to understand whether you have understand or not. What is axis of precision OY? Can anybody please repeat? Axis of precision म्हणजे काय? हे कोणाला कळले की नाही मला कळायला हवं. Yes?
Rotation of point X with respect to axis OY.
Yeah, this is also very, very correct definition, or you can say in such a manner that the axis about which the axis of spin precess or turn about the axis, that axis is nothing but the OY is called the axis of precision. Okay, and now tell me what is omega p. Now once you have understand that OY is nothing but the axis of precision, now tell me what will be the omega p. What will be the omega p? What will be the omega p? This is nothing but the omega p, na? So what is omega p? What is omega p? Can anybody define now what is omega? You have understand what is axis of precision. Axis of precision means what? the axis about which the axis of spin will turn. पण जेव्हा तुमची axis of spin, x of spin काय OX, ना OX जेव्हा तुमची टर्न होणार आहे तेव्हा त्याची काहीतरी अँग्युलर वेलोसिटी असणार आहे ना. बघा साधी गोष्ट आहे, when the disk is spinning, what is the angular velocity? Omega. So omega is nothing but the angular velocity of a disk which is spinning. Omega p is equal to the angular velocity. Now try to understand. Omega p is nothing but the angular velocity of axis of spin. Axis of spin. Okay, what is omega p? Omega p is nothing but the angular velocity at which axis of spin is turning about this axis of precision OI. So omega p is equal to angular velocity of axis of spin, which is equal to d theta upon dt. Okay, and this omega p is called as angular velocity of precision. What it is called as? It is called as omega p is called as angular velocity of precision. Okay, have you understand this? Now tell me you have understand or not. म्हणजे तुमची जी ऍक्सिस आहे ना, ऍक्सिस ऑफ स्पिन, ही ऍक्सिस ऑफ स्पिन किती वेलोसिटीनी टर्न होते या OI च्या भोवती. That is all about the omega p. So now I have helped you to understand omega. Now we have understand omega p. Now let us understand gyroscopic acceleration. Till now I haven't explained what is gyroscopic acceleration. Till now I have calculated total acceleration. What is total acceleration? Alpha. But this total acceleration alpha is not a gyroscopic acceleration. To understand the gyroscopic acceleration, first of all you have to understand this omega p. Now tell me, have you understand what is omega p? Omega p is called as the angular velocity of precision, and omega is called as the angular velocity of spinning. म्हणजे तुमची जी ऍक्सिस आहे OX ही एका ठराविक अँग्युलर वेलोसिटीनी टर्न होणार आहे कोणाच्या भोवती? या OI च्या भोवती, which is nothing but the axis of precision, and that is called as the angular velocity of precision omega p. Now message me fast, you have understand this concept or not? Message me fast, you have understand this concept or not? Okay, now I'll move forward. Now I have got a total acceleration. Now what is total acceleration? This total acceleration alpha is equal to d omega by dt plus omega into omega p. Okay, now this is the thing about the total angular acceleration. Now omega is nothing but the angular velocity of spinning, omega p is the thing but the angular velocity of precision. Now let us understand what is gyroscopic acceleration. Gyroscopic acceleration म्हणजे काय ते आपल्याला समजायचं. So for that, now this statement we have understand, the axis of precision is perpendicular to the plane in which the axis of spin is going to rotate. So when I will show you all the planes, you will get to understand this. Okay, now if the angular velocity of the disk remains constant, this is a condition. First of all, you try to understand the condition. Okay, here let us say that alpha is equal to, what is alpha? I will write dw upon dt plus omega into omega p. It is nothing but the alpha. So this is nothing but total angular acceleration. Okay, so this I have derived total acceleration alpha is equal to d omega by dt plus omega into omega plus is equal to alpha t plus alpha c. So this I have derived. Now let us say there is a condition or a case if the angular velocity of the disk remains constant at all position of the axis of spin. Means what? Your omega is constant. Means when omega, that is the angular velocity of a disk, remain constant at all positions of the axis of the spin. What will happen? म्हणजे काय? At OX position it is omega. At OX dash it is omega. At again OX double dash it is whatever will be the position of axis of spin. तुम्ही तुमची axis of spin जी आहे OX, त्याची पोझिशन किती पण चेंज होते, OX, OX dash, OX double dash, or maybe OX triple dash, whatever will be the position, this omega is constant. If it remains constant, then this dw by dt is 0. This dw by dt will be 0, बरोबर ना? Because there is no any change in, see, जर तुमचा omega जर तुमचा constant असेल, म्हटल्यानंतर the rate of change of d omega by dt will be 0 ना? And what is alpha t? Alpha t is nothing but a dw by dt, so that will be equal to 0. So if that is 0, So what I am getting, if that is 0, what I am getting, see, my total angular alpha omega is equal to dw by dt plus omega d theta by dt. Okay, but this is 0 because if the angular velocity remains constant, so I am getting alpha is equal to omega. But what is d theta by dt? Omega into omega p. And this alpha is equal to omega into omega p is called as what? Gyroscopic acceleration. Okay, this product omega into omega p, that is the axis of precision, angular velocity of axis of precision, and angular velocity of spinning body, the product of both is nothing but the alpha, and then it is called as a. So this was nothing but the total acceleration. And when this term means what? When alpha t is equal to 0, that is only alpha c, then omega into omega p is called as the gyroscopic acceleration. Now tell me, have you understood this gyroscopic acceleration or not? Is it clear? I hope you have understood what is omega p, what is axis of spin, what is axis of precision. Message me okay if you have understood this, so I can move forward. Okay. Now once you have understood this, okay. Now, so angular acceleration of the disk alpha is equal to omega into omega p. So this alpha is equal to omega into omega p is called as a gyroscopic acceleration. Gyroscopic acceleration. Okay. And now I have calculated gyroscopic acceleration. What is gyroscopic acceleration? Omega into d theta by dt, omega into omega. Now I want to calculate gyroscopic torque. Now next step is to understand what is gyroscopic torque or couple. Okay. So what is the next derivation? आता एवढं तुम्हाला कळलं असेल की आता सर दुसरं derivation कुठलं घेणार आहे, gyroscopic torque किंवा couple. So first of all, let us understand what is gyroscopic torque or a couple. Okay. The torque required to produce this acceleration. Which acceleration? Gyroscopic acceleration. The torque required to produce this gyroscopic acceleration. Now tell me first of all, हे गायरोस्कोपिक एक्सेलरेशन आहे ओमेगा इज इक्वल टू ओमेगा इंटू ओमेगा पी, हे कसं प्रोड्यूस झालं मी मागे जाते ते या फिगर मध्ये. नाउ टेल मी, दिस अल्फा इज इक्वल टू ओमेगा इंटू ओमेगा पी, दिस अल्फा इज इक्वल टू ओमेगा इंटू ओमेगा पी, दिस इज नथिंग बट द गायरोस्कोपिक एक्सेलरेशन. हे गायरोस्कोपिक एक्सेलरेशन कसं प्रोड्यूस झालं? आतापर्यंत आपण जे सगळं डेरिव्हेशन बघितलं याच्यामध्ये तुम्ही सांगू, कॅन यू एक्सप्लेन हाऊ दिस गायरोस्कोपिक एक्सेलरेशन आय हॅव कॅल्क्युलेटेड, बट हाऊ दिस प्रोड्यूस? How this produced? Can anybody tell me? हे का ऑटोमॅटिकली झालं का? Gyroscopic acceleration. Acceleration is rate of change of velocity with respect to time, ना? So you have to apply something to produce this acceleration. So tell me how this acceleration is produced. या फिगर मध्ये बघून तुमच्या लक्षात आलं पाहिजे आतापर्यंत. Yes, be fast and tell me. See, have you understand or not that alpha is equal to omega into omega p is a gyroscopic acceleration? How it is produced? Tell me anybody.
Due to turning of axis.
Due to the turning of axis. पण मला सांगा काय तुमच्याकडे जादू आहे का? ऑटोमॅटिकली एक्सिस टर्न झाली का? नाही.
Torque.
आता let us, you have to apply the torque. So let us say that I am applying a torque at this axis. I am applying a torque at this axis. Because you are applying a torque, so it is called as a applied torque. It is called as a applied torque or it is called as a applied couple. Okay. So when I am applying a torque or a couple on this axis, what happened? This axis came to the new position x dash. So when it came to the new position x dash, what happened? The axis recessed or axis turned about this axis, which is called as a OY, which is called as the axis of precision. Okay, and that is why this gyroscopic acceleration got produced. जर ही ऍक्सिस टर्नच झाली नसती, जर मी टॉर्क अप्लायच केला नसता आणि जर ही ऍक्सिस त्याच्या न्यू पोझिशनला आलीच नसती, मला सांगा तुमचा ओमेगा पी आला असता का? की ओमेगा पी विल बी इक्वल टू 0. इफ ओमेगा पी इज इक्वल टू 0, so what will happen? Alpha will be equal to 0. So there is no gyroscopic acceleration. I hope you understand this. I hope you understand this, that if the axis of spin never came to the new position or it never turned about the axis OY, your omega p was equal to 0. So alpha is equal to omega p into omega, that is equal to 0. So gyroscopic acceleration will be equal to 0. So what I mean to say, I have to apply some torque. I have to apply some torque to produce this gyroscopic acceleration, and or I have to apply some torque so that this axis of spin OX will rotate about this axis OY, and that torque is called as what? What is that torque called as? That torque is called as a gyroscopic torque. Okay, so that is what I have written here. The torque required to produce this acceleration, or torque or a couple required to precess the axis OX, is known as gyroscopic couple or gyroscopic torque. So this gyroscopic couple or gyroscopic torque is also called as a applied coupler or applied torque, and it is denoted by C. And now what is your next aim? What is your next aim? I have to calculate the formula for the C. So I have calculated a formula for omega, which is nothing but the gyroscopic acceleration, omega into omega p. Now to produce this acceleration, I have to apply some torque. So this torque is called as a C, which is called as a applied torque. Okay. Now your next aim is to derive the formula. Okay, so C is what? C is nothing but a gyroscopic couple. It is denoted by C.